Welcome, everyone, to another deep dive here on artificial intelligence unorthodox lessons.
Great to be here.
We're really excited you're joining us for what I think is a really insightful look into the practical side of AI consulting.
Yeah, it's a topic that comes up a lot.
And before we jump in, a big thank you to our sponsor, Notion Wave.
Absolutely.
They're a fantastic AI company doing some really cutting-edge work in research, education, and, well, a lot more. Their support really does make these deep dives possible.
It certainly does. So today, we're kind of zeroing in on something pretty crucial, really, whether you're looking to hire AI consultants or maybe even become one.
Right.
We've got some great material outlining, the typical stages, the key things to think about.
And our mission today, I suppose, is to unpack all of that.
Exactly. Unpack those phases, pin down the critical questions you need to ask at each step, and maybe highlight some of those nuances that can trip people up.
Those sneaky details.
Yeah, the goal is to give everyone a clear, kind of actionable roadmap for what a good AI consulting project actually looks like.
Okay, so where do we start? Phase one.
Phase one, business understanding. And the core question, it sounds simple, but it's surprisingly deep. What does the business really need?
Right. It's so tempting to just leap to, we need AI. But like you said, there are layers. First off, really digging into the fundamental business objectives. What problem are they actually trying to solve? What's the end game?
Exactly. It can't just be about deploying AI for its own sake. There has to be a real business outcome driving it.
And that naturally leads to the next bit, right? The cost-benefit analysis.
Yes. And the sources mention something called the expectation complexity framework. That sounds pretty practical.
It really is. And it's funny how often this gets maybe not ignored, but glossed over.
Uh-huh.
Think about it. If a business wants some revolutionary AI, super complex to build, but their budget is tiny, well, that's a bit of a red flag, isn't it?
Yeah, a big one. Or the opposite. Maybe a simple AI could give huge value, but they don't see the potential.
Exactly. So this framework helps balance those hopes, those expectations with the actual technical complexity involved, finding that realistic middle ground.
It's about managing expectations from the get-go. You see that clash quite a bit, don't you? The initial excitement versus the technical reality.
Oh, definitely. It's easy to dream big, harder to build it.
You don't want to bring a supercomputer to solve, like, a basic spreadsheet task.
Or try building a self-driving car on a bicycle budget.
Precisely. So, okay, we've got the business objectives, we've run the cost benefit. What else is in this first phase?
Then we get into defining the technical goals. How do we translate that big business picture into something concrete for the project?
Right, so
What specific problem is AI tackling? And crucially, how do we measure success technically? What are the metrics?
use like accuracy, maybe?
Yeah, accuracy is a common one. What level is good enough? What about response time? Does it need to be instant? How scalable does it need to be?
All those need clear definition up front, moving from the business why to the technical what.
Exactly, making it tangible for the data scientists, the engineers.
Okay, and the last piece of this business understanding phase, the execution plan. What does that actually involve?
That's basically the project roadmap. It lays out the specific tech, the tools needed to hit those technical goals.
So infrastructure, languages.
Yep. What servers or cloud services? Which programming languages, AI libraries are the best fit? What are the key milestones? The timeline. It's the blueprint, really.
The how.
It really brings up an interesting point, though. How often do businesses come to the table without having thought through these technical bits?
More often than you might think, honestly. They might have this great vision, AI transforming everything.
But not the practicalities.
Exactly. They lack the understanding of what it takes kind of under the hood to make it happen. And that's where good consulting really adds value.
Makes sense. Okay, so we've laid the foundation, understood the business needs. What's the next logical step?
Then we dive into data understanding. The big questions here become, what data do we actually have? Or what do we need? And the really big one, is it clean? Is it any good?
Ah, data. The fuel for the AI engine, as they say.
That's the one. And this phase is all about checking the quality and the quantity of that fuel. It starts with selecting the right data.
It's not just grabbing everything you can find, is it?
No, definitely not. There needs to be a clear reason why you're choosing certain data. And just as importantly, why you're not choosing other data. You need to be intentional.
And I guess that selection might change as you learn more.
Oh, absolutely. You might start thinking one data set is key, but then you explore it and find unexpected things that make you rethink your whole data strategy. It's iterative.
Okay, so after selection comes the initial data collection. How does that usually work?
Well, it really varies. Could be pulling from existing company databases, maybe setting up new ways to capture information, scraping public web data, or even running small pilot studies to generate specific data points.
Lots of possibilities.
The key is having a clear plan for how you're gathering it and documenting everything.
Got it. So once we've gathered some data, we need to get to know it. Describe its surface properties.
Exactly. What are its basic characteristics? What kind of data is it? Structured, like in tables. Unstructured text or images. Is it numbers, categories? You look at basic stats just to get a feel for it.
Like taking inventory before you cook.
Perfect analogy.
Yeah.
And then we move into actually analyzing it, digging a bit deeper.
Looking for patterns, relationships.
Precisely. Trying to spot correlations between different bits of data, finding any weird outliers that need a closer look, just trying to get those first insights. Visualizations like charts and graphs are super helpful here.
Makes sense. Spotting trends visually. Now, data quality. The sources highlighted this as a potential minefield. How do you assess how good the data actually is?
Yeah, that's a critical step. Data quality isn't just one thing. You look at accuracy. Is the information correct? Completeness, are there lots of missing bits? Consistency, is the same info recorded differently elsewhere? Validity, does it follow the expected rules and formats? And timeliness, is it recent enough?
Wow, lots to check.
You might run checks for missing values, flag weird data points, compare across different sources, and you have to decide what level of quality is actually acceptable for this project.
Because aiming for absolutely perfect data might be impossible or just too expensive.
Exactly. The effort to get perfect data might not be worth the small improvement it gives the model. It's finding that sweet spot, that good enough point.
Right.
And this phase also involves some, initial thoughts about what machine learning models might work given the data we've seen.
So just brainstorming at this point, based on the data type.
Pretty much. If you've got lots of labeled data for, say, customer segments, you might start thinking about classification models like decision trees. But yeah, it's still very exploratory.
Okay, so we've explored the data landscape, got some early model ideas. What's next?
Now we get into data preparation. And the question shifts to, how do we actually organize this data, clean it up, transform it so the models can learn from it effectively?
Right, preparing the ingredients for the AI recipe.
You got it. And this often involves refining the data selection again. It wasn't just a one-off decision back in the understanding phase, was it?
No, it sounds like it's often iterative. As you understand the data and the models better, you might realize you need something different.
Exactly. Maybe you need more of a certain type of data, or maybe something you thought was crucial turns out to be less useful. That constant check on the why behind the data choices is still really important.
Okay, so more focused selection, then maybe more targeted data collection if needed.
Yep, you've got a clearer picture now of exactly what's required and how best to get it.
And then comes data cleaning. The sources really stressed this noisy, missing, wrong data. Sounds like it can take a lot of time.
Oh, it absolutely can. And it's often the part people underestimate the most.
Right.
But you have to deal with these quality issues. Like the sources said, garbage in, garbage out.
Right.
So cleaning involves maybe handling outliers, deciding what to do with missing values, fill them in somehow, or just remove those records, correcting errors you find. It's meticulous.
Like prepping the canvas before painting. Gotcha. What about constructing new attributes? Feature engineering. That sounds interesting.
Yeah, that's the art and science bit.
Yeah.
You take the raw data and create new features from it that might give the model better signals.
Like if you have transaction data.
You might calculate average purchase value or how often someone buys. Those engineered features could be way more predictive than just the raw transaction details.
Clever. Taking the raw stuff and making it more informative. And integrating data from different places. That sounds potentially complicated.
It certainly can be, especially if the sources use different formats or terms. But combining data often gives you a much richer picture, leading to better models. It just requires careful mapping and resolving inconsistencies.
Okay. And the final step in preparation, formatting the data for the specific models. You mentioned the word to-vec example for text. What else?
Yeah, that's crucial. Depending on the algorithm, you might need to scale numbers so they're all in a similar range, stops models getting skewed by big numbers. You might need to encode categories, like turning red, green, blue into numbers the model gets, or just reshaping the data into the exact structure the model expects. That word to vac example really shows how vital formatting is.
Makes sense. Okay, data's prepped, clean, formatted. Now we finally get to the bit everyone thinks of, model training. The question being, what techniques do we actually apply?
Yes, this is where we start building and playing with different AI models. And like the sources said, picking the right techniques is key. Different data, different problems need different approaches.
Right, a model for images won't work for time series data.
Exactly. The sources mentioned examples like random forest, XGBoost, deep learning. How do you choose?
Good question.
Well, it depends on your prepared data, how complex the business problem is, how much data you have, even how interpretable you need the model to be.
Interpretable, like understanding why it makes a prediction.
Yeah. Simpler models like random forests can be good for that. For really complex stuff, maybe with images or text, deep learning might be better, but it usually needs more data and computing power.
Trade-offs.
That's
And the actual training involves splitting the data. Why do we do that?
right. You typically split it into 3 sets: training, validation, and test.
Okay.
The training set is what the model learns from. The validation set is used during training to tweak settings, hyperparameters, and stop the model just memorizing the training data, which is called overfitting.
So it performs badly on new data if it overfits.
Exactly. And the test set, you keep that totally separate until the very end. It gives you a final, unbiased look at how the model does on data it's never seen.
Like practicing quizzes before the final exam. Makes sense. And this phase isn't just running code, right? It's assessing the models.
Definitely not just running code. You have to compare how the different models performed using those success metrics we defined earlier.
Accuracy, precision, recall, those things.
Yep, or others,
Hmm.
depending on the problem. And it's a great point your source has made. While people think coding the model is AI, with today's tools, that part is often less involved than all the data work that came before.
Interesting.
The real skill is knowing which models to try, how to tune them, and how to read the results in light of the business goals.
It's more than just coding chops. So we've trained some models, now we need to pick the best one. That brings us to model evaluation, the key question. Which model actually meets the business objectives?
Exactly. Now we look beyond just the technical stats like accuracy. We circle right back to those original business success criteria.
Does it actually deliver the value we wanted, reduce cost, improve efficiency?
Precisely. Does the technical performance translate into real-world business impact? And this phase needs a really thorough review.
Looking back at the whole process,
Yeah, questioning everything. Were our early assumptions right? Was the data prep good enough? Were the model choices sound? It's critical self-assessment.
and based on that, you often need to retrain or refine the model. It's not usually one and done.
Almost never. You might tweak settings, try different algorithms, maybe even go back and prep the data differently based on what you learned.
The sources mentioned experiment management systems here to keep track of everything.
Oh yeah, crucial when you're trying lots of different models and settings. And what's really interesting is how real-world business constraints often come into play here, beyond just standard ML metrics.
Like you mentioned before, needing fast response times, how does that impact evaluation?
Hugely. You might have a super accurate deep learning model, but if it takes seconds to give an answer, it might be useless for a real-time application.
So you might choose a slightly less accurate but faster model.
Exactly. You might need a less computationally heavy technique. Those practical operational needs are often just as important, maybe more so, than pure statistical scores in a lab.
The best model on paper isn't always the best model in practice. Got it. So we've evaluated, refined, chosen our best fit model. Final phase, model deployment.
That's it, model deployment. The question now is, how do we get this thing out of the lab and into the hands of the people who need to use its results?
Making the theoretical practical. A clear deployment plan sounds essential here. What goes into that?
It needs to spell out exactly where the model will run, cloud, on-premise servers embedded in software.
Uh-huh.
It details the tech infrastructure needed, how other systems or users will talk to it, like APIs, and the process for rolling out updates later on.
And deploying it isn't the end of the story, is it? Post-deployment.
Absolutely not. You
Yep.
need a solid monitoring and maintenance plan. You have to keep watching how it performs in the real world.
Checking its accuracy doesn't degrade over time.
Exactly. Monitor key metrics, look for problems, and you need processes for retraining or updating it as the data changes or business needs evolve. Things change, models need to keep up.
So that ongoing work is key for long-term value. And then there's a final report.
Yep. Summarizing the whole project. Business objectives, data used, models explored, how the final one was picked, deployment details, the maintenance plan. It's the complete record.
And the very last step seems to be reviewing the whole engagement, learning lessons.
It's exactly. Asking, what went well? What were the bumps in the road? Wow. How can we do better next time? That continuous improvement mindset is vital for really successful AI development.
Wow. So yeah, as we've kind of walked through, AI consulting is definitely a journey with many steps.
It really is.
From getting that deep business understanding right at the start, all the way through to making sure the deployed model keeps working well, every phase needs real care and focus on answering those key questions.
And like we discussed, while model training gets a lot of attention, that foundational data work, understanding it, preparing it, is often just as critical, maybe even more so.
So key takeaways then. Number one, start with crystal clear business objectives.
Absolutely. Number two, really investigate and prepare your data thoroughly. Quality is everything.
3, model choice and training matter, but evaluate against the business goals ultimately.
Yep. 4, don't forget deployment and ongoing maintenance. That's where the long-term value comes from.
And 5, continuous review and improvement. Always be learning.
Couldn't have said it better myself.
Well, we really hope this deep dive has given everyone a more structured, maybe more insightful view into AI consulting.
Hopefully demystified it a bit.
And if you found this valuable and want to explore more essential, practical AI topics, please do make sure to follow Artificial Intelligence Unorthodox Lessons wherever you get your podcasts or audio content.
Yeah, we'd love to have you join us for future explorations.
Absolutely. Thanks for tuning in.